Welcome to the session on trigonometric identities and equations, angles in all four quadrants. The objectives for this session are to calculate the sine, cosine and tangent of any angle. We will begin this session by introducing the definitions of cos, sine and tan. However, in order to do this, we need to consider a unit circle first. A unit circle is a circle with a radius of 1 unit, as shown in the diagram. For a point P at xy on a unit circle, such that OP makes the angle theta with the positive x-axis, we have cos theta equals the x-coordinate of P, and sine theta equals the y-coordinate of P. We also have that tan theta equals y over x, which is the gradient of OP. Notice that we measure positive angles theta anti-clockwise from the positive x-axis. We will now use these definitions to find the sine, cosine and tangent of any angle theta. Let's consider this angle theta. As you can see, it is obtuse. However, the definitions remain the same. When theta is obtuse, cos theta, however, is negative because the x-coordinate of P is negative. We are going to use these definitions of cos, sine and tan to generate graphs of sine theta and cos theta. Let's consider sine theta first. We have the unit circle before us and an angle of 45 degrees, as you can see in the unit circle. This corresponds to the value as denoted here. The value 90 degrees is denoted here, and the value 270 degrees is denoted here. We've plotted the points, as you can see. As P moves around the circle, you can plot y equals sine theta by reading off the y-coordinate, as shown. What about cos theta? This time we have the x and y axes as shown. So 45 degrees corresponds to the value here. Next, we have 0 degrees as shown. And now 180 degrees. And we've plotted the points, as you can see. As P moves around the circle, you can plot y equals cos theta by reading off the x-coordinate, as shown. Notice that the point P corresponding to the angle theta is the same as the point P corresponding to the angle theta plus 360 degrees. So graphs y equals sine theta and y equals cos theta are periodic with period 360 degrees. Let's now take a look at an example. Pause the video and have a go. Press play when you're ready to view the solutions. Now let's have a go at example 1a. We are first required to find the value of sine 180 degrees. So let's solve this. Here's the unit circle. And here's the angle theta, which is 180 degrees in our example. The coordinates corresponding to this are -1, 0, as shown. So therefore, x equals cos 180 degrees, which is the definition, which equals minus 1. And y equals sine 180 degrees, which is again from the definition, which equals 0. We're now going to have a look at sine 270 degrees and cos 270 degrees. For theta equal to 270 degrees, we have the coordinates 0, minus 1, as shown. Therefore, x equals cos 270 degrees, which equals 0, and y equals sine 270 degrees, which equals minus 1, as shown. What about sine minus 90 degrees? For theta equal to minus 90 degrees, we have these coordinates. We're going clockwise this time as we're considering a negative angle. And so minus 90 degrees is actually equivalent to 270 degrees. So again, we're considering the point 0, minus 1. And so x equals cos minus 90 degrees, which equals 0, and y equals sine minus 90 degrees, which equals minus 1. And now let's take a look at cos 90 degrees. For theta equal to 90 degrees, we have these coordinates, 0, 1. Therefore, x equals cos 90 degrees, which equals 0. And y equals sine 90 degrees, which equals 1. And finally, let's consider cos 630 degrees. 630 degrees is clearly greater than 360 degrees. And since the graphs are periodic, with period 360, this is equivalent to 630 minus 360 degrees, which is equal to 270 degrees. So for theta equal to 630 degrees, we have the coordinates 0, minus 1 again. So x equals cos 630 degrees is equal to 0. And y equals sine 630 degrees is equal to minus 1. Now let's take a look at example 2. Pause the video and have a go. Press play when you're ready to view the solutions. So let's have a go at this. This time we're considering multiples of 45 degrees. We are first going to consider the 45-degree angle in the unit circle. For theta equal to 45 degrees, we have coordinates 1 over root 2, 1 over root 2, as you can see. So therefore, x equals cos 45 degrees equals 1 over root 2, and similarly for y equals sine 45 degrees. And this indeed is the length of OP, because x squared, which is 1 over root 2 squared, plus y squared, which is 1 over root 2 squared also, equals 1. So now let's calculate part A, tan 45 degrees. For theta equal to 45 degrees, we're considering the coordinates 1 over root 2, 1 over root 2 in the unit circle. And therefore, cos 45 degrees is 1 over root 2, y equals sine 45 degrees is also 1 over root 2. Tan theta equals y over x. So let's substitute the values of y and x. So here's y, and here's x. And of course, dividing one by the other gives us 1. So tan 45 degrees equals 1. And now for sine minus 135 degrees. Again, we're going to go clockwise because this is a negative angle. So this is minus 135 degrees. And the coordinates are minus 1 over root 2, minus 1 over root 2. And the positive angle, of course, is 225 degrees. And therefore, cos minus 135 degrees equals minus 1 over root 2. And y equals sine minus 135 degrees equals minus 1 over root 2 also. Now let's take a look at sine minus 225 degrees. Again, we have a similar idea. Here's the angle, and here are the coordinates. And here's the positive angle. Therefore, we have x equals cos minus 225 degrees equals minus 1 over root 2. And y equals sine minus 225 degrees equals plus 1 over root 2. Now let's have a go at part D. We are required to find tan 90 degrees. For theta equal to 90 degrees, we have the coordinates 0, 1. Here, x equals cos 90 degrees and y equals sine 90 degrees. Therefore, using the coordinates and the angle, we have x equals cos 90 degrees equals 0 and y equals sine 90 degrees equals 1. And therefore, substituting in the formula for tan, which is y over x, we have sine 90 over cos 90, as shown. And clearly this is undefined due to the zero divisor. And therefore, tan is undefined for all odd multiples of 90 degrees. Tan will look something like the sketch you can see on your screen now. And here we have asymptotes, where x equals minus 270, minus 90, plus 90, 270, 450, and so on. And the curve approaches the asymptotes here. Now let's have a go at part E. We are required to find the value of tan 360 degrees. So let's solve this. For theta equal to 360 degrees, we have the coordinates 1, 0, as shown. Therefore, x equals cos 360 degrees equals 1, and y equals sine 360 degrees equals 0. And therefore tan 360 degrees is equal to y, which is sine 360 degrees, which is 0, over x, which is cos 360 degrees, which is equal to 1. So therefore, tan 360 degrees is equal to 0. Now let's have a go at part F and calculate cos 405 degrees. Again, this is greater than 360 degrees. So 405 degrees is equivalent to 405 degrees minus 360 degrees, which is of course equal to 45 degrees. So let's have a look at theta equal to 405 degrees. Our coordinates at this point are 1 over root 2, comma 1 over root 2, as shown, because this is a complete turn of the circle plus 45 degrees. So x equals 405 degrees is 1 over root 2, and similarly for y. So here's x equals cos 405 degrees equals 1 over root 2, and here's y equals sine 405 degrees, which equals 1 over root 2 also. Now let's take a look at some more theory. The four quadrants. Angles always lie in one of the four quadrants, even if they are greater than 360 degrees. So for example, 500 degrees equals 500 degrees minus 360 degrees, which is 140 degrees. Let's take a look at an illustration. Here are the x and y axes. And here's a point on the unit circle. And theta is the angle corresponding to this point on the unit circle. X is equal to cos theta, as we've defined it, and y equals sine theta, as we've defined that also. This is the first quadrant, and we begin at 0. Here's 90 degrees, and we go into the second quadrant, between 90 degrees and 180 degrees. After 180 degrees, we go into the third quadrant, and we stay in the third quadrant up to 270 degrees. And then the fourth quadrant is from 270 degrees to plus 360 degrees. And of course this is the same as 0 degrees. Now if we go the other way, we're at minus 90 degrees here in the fourth quadrant, so between 0 degrees and minus 90 degrees. And we're in the third quadrant from minus 90 degrees to minus 180 degrees. In the second quadrant from minus 180 to minus 270. And finally from minus 270 to minus 360, or 0 degrees, we're back in the first quadrant. So as you can see, x equals cos theta is positive, and y is also positive, and tan is also positive in the first quadrant. In the second quadrant, x is negative, y is positive, and since tan is defined as y over x, tan is negative. So sine is the only one out of the three which is positive. In the third quadrant, x is negative, y is negative, and of course, since tan is defined as y over x, tan is positive. So tan is the only one which is positive out of the three. And finally, in the fourth quadrant, we have that x is positive, y is negative, and therefore tan is also negative. So cos is the only one of the three which is positive. So here's a summary. One way of remembering this is cast, C-A-S-T. It is also known as the cast diagram. As shown. Using these rules, we can find sine, cos, and tan using the corresponding acute angle made with the x-axis. So let's take a look. Here's an illustration. Here are different ways in which we can see theta. 180 degrees minus theta has been highlighted, as you can see. Here, sine 180 minus theta is equal to sine theta, where theta is an acute angle. And tan 180 degrees minus theta equals minus tan theta, and cos 180 degrees minus theta is minus cos theta. However, if we're considering 180 degrees plus theta, we have that tan is positive. So tan 180 plus theta is equal to tan theta. However, the case for cos and sine is different. Cos 180 plus theta is minus cos theta, and similarly, sine 180 plus theta is minus sine theta. And finally, let's consider cos in the fourth quadrant. Cos 360 degrees minus theta, as highlighted, equals cos theta. However, sine and tan are both negative in this quadrant, so sine 360 degrees minus theta is minus sine theta, and tan 360 degrees minus theta is minus tan theta. Let's now take a look at an example using these laws. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve this. For example 3a, we are required to express sine minus 110 degrees in ratios of acute angles. So let's take a look at the cast diagram. Minus 110 degrees is as shown. The angle lies in the third quadrant. It makes an acute angle with the x-axis of 70 degrees. Now in this quadrant, only tan is positive. as you can see. And therefore sine minus 110 degrees equals minus sine theta, or in our example, minus sine 70 degrees. Now let's solve example 3b. Express cos 325 degrees in ratios of acute angles. So here's 325 degrees in the cast diagram. The acute angle is 35 degrees. And as you can see, because this is in the fourth quadrant and only cos is positive in this quadrant, we have that cos 325 degrees is equal to cos 35 degrees. And now finally let's solve example 3c. We are required to express tan 515 degrees in ratios of acute angles. Again, here's the cast diagram. Here's 515 degrees. Remember, this is one complete rotation plus another rotation, which is partial, and the partial rotation is 90 degrees plus 65 degrees. So as you can see, we're in the second quadrant, and therefore we're making an acute angle with the x-axis of 35 degrees. Here, only sine is positive in this quadrant, and therefore tan is going to be negative when expressed as an acute angle. So tan 515 degrees equals minus tan 35 degrees. This brings us to the end of this session. If you have understood its contents, you should be able to calculate the sine, cosine, and tangent of any angle. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.